Hey everyone, I'm back. I survived my last finals for my pharmacy doctorate program. Yes! Woo! Yes! Woo! It does feel surreal. I don't know how long it's going to take to realize that I am completely done with finals. And that's been going on. I've been taking finals for years, so to be actually done with finals is amazing. As I promised, I'm coming in with a more in-depth video for all you nerds and professionals about the endocannabinoid system. This video we're going to focus on endogenous endocannabinoids, and I will be making more videos on the CB1 receptor, the CB2 receptors, as well as the pharmacology of the endocannabinoid system, so stick around. This video we're going to be focusing on endogenous cannabinoids as well as the biosynthesis of them, so let's get started. The two most common and well-known endogenous cannabinoids are anandamide acid and 2-arachidonyl glycerol, 2-AG. I'm just going to say 2-AG to save your ears from me trying to pronounce that word. Sorry. Anandamide acid was discovered in 1992, and then 3 years later, 2-AG was discovered. Both of these endogenous cannabinoids are neutral lipids that are conjugated to arachidonic acid. They are both synthesized in the postsynaptic terminal of neurons, and just for simplicity, I'm going to be focused on neurons and CB1 receptors for this lecture. Once these endogenous cannabinoids are synthesized in the postsynaptic terminal of the neuron, they transverse back to the presynaptic terminal. This is known as retrograde transmission. The reason why this is called retrograde neurotransmission is because normally or typically we think of neurotransmission beginning at the presynaptic terminal of neurons, where the neurotransmitters or signals can be synthesized and then they actually flow out towards the postsynaptic terminal where they modulate signals or transformations. However, with endogenous cannabinoids, they're being synthesized in the postsynaptic terminal of neurons and they're transversing back to the presynaptic terminal where they're going to have all their actions occur. The CB1 receptor is actually located on the presynaptic terminal. Activation of CB1 receptor via endogenous cannabinoids elicits a whole bunch of different changes to that neuron. One of the main ones we're focused on actually is the inhibition of the release of vesicles from the presynaptic terminal. 2-AG synthesis begins with phospholipid phosphatidylinositol 4,5-bisphosphate, also known as PIP2. Let's just go with PIP2 because I'm horrible at pronouncing stuff and enunciating stuff if you haven't learned. PIP2 is converted to diacylglycerol, also known as DAG, an intermediate, via phospholipase C-beta, also known as PLC-beta enzyme. DAG reacts with glycerol, then it is converted to 2-AG via DAG-L, which is DAG lipase. DAG-L is a multi-pass integral membrane enzyme consisting of two stereoisomers, alpha and beta. DAG-L alpha is mostly expressed in neurons and some in supportive cells. Distribution of DAG-L alpha decreases 2-AG levels within the brain, which leads to impairment of synaptic plasticity. DAG-L beta is mostly found in support cells like microglia. DAG-L alpha is actually absent in these support cells mostly. A small number is found within the CNS. And when I say a small number, I do mean DAG-Al beta. Synthesis of anandamide differs from 2-AG in that it is a very complex system involving many enzymes. Membrane phospholipid in arachidonyl phosphatidyl ethanol, also known as NAPE. We're going to go with NAPE once again because I'm horrible at pronouncing stuff, is the precursor for anandamide synthesis. From here, the synthesis of anandamide has various pathways which differ depending on the brain region. Anandamide synthesis can be simplified in a two-step pathway consisting of a calcium-dependent N-acyltransferase, known as NAT, and N-acylphosphatidyl ethylamine hydrolyzing phospholipase D, also known as NAPE-PLD. NAPE is formed when NAT catalyzes the transfer of arachidonic acid from phosphatidylcholine to phosphatidylethylamine. Anandamide is formed when NAPE-specific phospholipase D, also known as NAPE-PLD, hydrolyzes NAPE. Hydrolysis of NAPE forms anandamide acid. Alright, so that's the basics of the endogenous cannabinoids for anandamide and 2-AG, as well as their biosynthesis. I will be working on a more in-depth video regarding the receptors as well as the pharmacology. I think I'm going to break it up to small little videos. That way I don't drag this on and have like a 30-minute discussion. That's not what I'm going for here. So thank you for watching, and please subscribe to my channel. Please like my videos, as well as go check out Cannabis Connection University. They have amazing videos as well.